Hello, we are discussing about GATE 1991 ECE paper solutions. The topic we are discussing is electron devices. This is sixth one mark question came in GATE 1991. The built-in potential of the gate junction for an n-channel JFET is 0.5 volts and the drain current saturates at VDS of 4 volts when VGS is equal to 0 volts. Then the pinch-off voltage is given thing is built-in potential of gate junction for an n-channel JFET is given, and when the drain current is getting saturated, that is becoming constant, is also given. We need to calculate the pinch-off voltage. First of all, we should know the pinch-off voltage definition. The correct answer for this question is minus 4 volts. We see the details now. We know that every JFET is consisting of two characteristics. One is drain or output characteristics, the other is transfer characteristics. With respect to drain or output characteristics, drain or output characteristics are always between drain current versus drain to source voltage at a constant gate to source voltage, that is ID versus VDS at constant VGS. So this is, if you look at this diagram, drain current is on y-axis and drain to source voltage is on x-axis VDS, and this is 0. Whenever VGS is equal to 0, VGS is equal to 0, that is nothing but gate and source are shorted. So that is nothing but JFET drain characteristics with shorted gate. Then you will get the characteristics in this way. As VDS increases initially, the drain current increases linearly as VDS increases. For larger values of VDS, drain current becoming saturates at point B, and after that, even though if you increase the VDS, it will be constant, it won't increase no more. So after, at very large VDS, it may get breakdown. So what is the minimum amount of drain to source voltage at which drain current becomes saturate? That too for VGS is equal to 0. That point is called as pinch-off voltage. So from this characteristic, this is the point, this is the minimum value of VDS on this curve at which drain current becomes constant when VGS kept at 0 volts. So pinch-off voltage is the minimum drain to source voltage at which drain current becomes constant when VGS is equal to 0. This when VGS is equal to 0 is very important. Only for this curve it is going to be treated as pinch-off voltage. Pinch-off voltage with respect to drain is only defined for VGS is equal to 0, not for any other value of VGS. Next, the other characteristic is, if you look at this one, let us assume if you are going with VGS of minus 1 volt instead of 0, let us assume this is VGS 0 where you are getting this one dotted line which is pinch-off voltage. If you keep VGS as minus 1 volt for N channel, as you are applying VGS of minus 1, that makes gate source junction more reverse bias. Whenever it is more reverse bias, more depletion layer width. More depletion layer width is nothing but effective channel width gets reduced. So the effective channel width becomes smaller. Whenever the effective channel width becomes smaller, at that time less drain current results. So if you observe this one, VGS is equal to 0, you will get a larger current, and if you apply VGS is equal to minus 1 volt, the drain current reduces and it is becoming constant at lesser value of VDS compared to the previous case. This is previous case, whereas VDS, for this VDS itself, the drain current becomes constant. So at this point drain current is becoming constant, but we cannot say it as pinch-off voltage. Pinch-off voltage is defined only when VGS is equal to 0, that is only when complete channel is available for conduction, not with respect to depletion region. Remember that one. If you apply VGS is equal to minus 2 or minus 3, that is as you are applying more and more reverse bias across gate source junction, then drain current becomes less and less. So by that time it is going to becoming constant for even smaller values of VDS. All those VDS values will not be treated as pinch-off voltage. So pinch-off voltage is strictly defined for drain characteristics with a constraint that when VGS is equal to 0. when VGS is equal to 0, at which value of VDS drain current becomes saturates, that will be treated as pinch off voltage. This is the point. Okay, and if you increase VGS like this, at that time at one point of VGS the drain current will become completely 0. That is called as VGS off. VGS off is the minimum amount of VGS in negative voltages. Minimum amount of VGS required to keep drain current required to maintain drain current 0. Now we will define pinch off voltage with respect to transfer characteristics. Pinch off voltage is minimum gate to source voltage at which channel becomes pinched off. That is, drain current becomes 0 even VDS is applied. Transfer characteristics is always between ID versus VGS at a constant VDS. That is, transfer characteristics always between drain current versus gate to source voltage at a constant drain to source voltage. So when VGS is equal to 0, you will get large current, that is treated as IDSS. IDSS is nothing but drain to source saturation current when VGS is equal to 0. You cannot apply VGS as positive voltage for the gate source junction, because the intention of JFET is to maintain high input impedance. That high input impedance is possible only when gate source junction is reverse bias. That can be achieved either by giving negative voltage for N channel JFET or at most 0 voltage. If you apply positive voltage, gate source junction becomes forward bias. By that time the important thing of high input impedance cannot be achieved. So VGS value for N channel is always negative. As you are applying more and more VGS, minus 1, minus 2, minus 3, the drain current is going to be getting smaller, because the depletion layer becomes larger, effective channel length gets reduced. At this point the drain current becomes 0. If you apply more than this one also, minus 4, minus 5, minus 7, minus 17 like this, the drain current will be 0 only. So we can define pinch off voltage is the minimum gate to source voltage. Look at the symbol, modulus of VGS. Okay, so VGS minus 3, that is nothing but minimum. If it is minus 3, you can apply more than that one, minus 4, minus 5, in that way. Pinch off voltage is the minimum gate to source voltage at which channel becomes pinched off. That is, drain current becomes 0 even VDS is applied. Remember that one, even VDS is applied. Okay, so this transfer characteristics can be classified into again 3 regions: cutoff region, linear region, and saturation region. Above this one it is saturation, below this one linear region, and after this pinch off voltage it is cutoff. So now we are discussing about the pinch off voltage, one with respect to drain, the other with respect to gate. But VP, pinch off voltage, which is having positive voltage with respect to drain, having negative voltage with respect to gate. Out of these two things, which will be treated as original pinch off voltage, which will be specified in data sheets? Original pinch off voltage is nothing but gate to source pinch off voltage, which is also called as VGS off. So VGS off is also called as VP. The magnitude of that one is nothing but always negative in case of N channel, always positive in case of P channel JFET. Okay, but with respect to drain characteristics, we know the magnitude of pinch off voltage. So from the question, in question it is given as drain current is becoming constant, that is saturated, when VDS is equal to 0 and VGS is equal to 0 volts. That is what the actual definition of pinch off voltage with respect to drain characteristics. So the value of pinch off voltage magnitude is 4 volts, but actual pinch off voltage is negative for N channel. So VP is nothing but minus 4 volts. VP with respect to VGS is the original, so it is also called as VGS off, whose value is nothing but minus 4 volts. This is the pinch off voltage required. Thank you. So the correct option for this one is nothing but minus 4 volts.